Hi friends, welcome to the last episode of the groundwater series. In this episode, we are mainly dealing with the groundwater exploration. The demand of groundwater and other requirements of the man is expected to increase tremendously with rise in population. Hence, the geologist has to equip himself with latest technologies available for exploration and exploitation of this resource. Exploration of groundwater is to locate aquifers capable of yielding water of suitable quality in economic quantities for drinking, irrigation, agricultural and industrial purpose and by various techniques. Assessment of groundwater resource range in scope and complexity from simple, qualitative and relatively inexpensive approaches to rigorous quantitative and costly assessments. Trade-offs must be carefully considered among the competing influences of the cost of an assessment, the scientific defensibility and the amount of acceptable uncertainty in meeting the objectives of the water source decision maker. Next is prospecting groundwater sources. Various types of investigations. Mainly there are three types: geological investigations, geophysical investigations and investigation using remote sensing. First one is the geological investigation. These study involve geological mapping of the area for an accurate information regarding the lithological character, study of mode of origin and petrological features of the rock both on surface and depth. Next is the study of aquifer structure with special stress on its exposure and relation with other material. For the first test drilling has to be conducted. After collecting information from the hydrogeological maps, aquifer test well is digged in the area of investigations. These test well provides accurate information on exact nature of the geological material with depth, capacity of various formations to yield water and quality of water available. Coming to the geophysical investigations. Geophysical investigations for groundwater are based on the rock formation, differ in their gravitational, magnetic, seismic and radioactive character. Why we do this? The behavior of the water bearing formations towards test involving these properties generally different than of water free rocks of the same type. So, that is why we are using this type of techniques. So, geophysical exploration for groundwater reserves involve both surface and subsurface techniques. You have to use both surface and subsurface techniques for the geophysical explorations. Next is the geophysical methods. It includes electrical methods or otherwise known as resistivity method, magnetic methods, electromagnetic methods, gravimetric methods, seismic methods. These are all included under the category geophysical methods. Coming to the electrical methods, it depends on the difference in electrical conductivities of different rocks and minerals. Actually, the rocks are having different characters and this depends upon the difference in electrical conductivity of rocks and minerals. The ability of material to conduct electric current is expressed as the ratio between an electrical potential difference and the resulting current is called electrical resistance and it is usually measured in ohms. In the case of dry rocks, aquifer and sediments, dense, compact and porous rocks will offer a great resistance to the electric current compared to loose, porous and wet and saturated samples of these materials. Dry rocks and wet rocks both are having different type of porosity and all. And in this method there are mainly two types of methods used, that is Venner configuration and Schlumberger configuration. So, in the resistivity method we are using two techniques, that is, first one is Venner configuration and the second one is Schlumberger configurations. Coming to the Venner configuration, here in this type, two electrodes M and N are placed in a line with current electrodes A and B, all the four being situated equidistant from one another and disposed symmetrically with respect to a central point. So, here Venner configuration consists of 4 electrodes, M and N placed in the current electrodes, and A and B refers to the current electrodes, M and B refers to the 2 electrodes, and they are placed or situated equidistant from one another. So, this is the configuration for Venner arrangement. Coming to the Schlumberger configuration, in this type we are also using 4 electrodes, and the 4 electrodes are placed in a line, but the distance between the current electrodes AB is more than 5 times the distance between the potential electrodes M and N. Only difference is the distance between the current electrodes and the potential electrodes is different. So, this is the Schlumberger configuration. Next method is seismic method. These methods based on the observation of velocity of elastic waves through the subsurface formation. So, actually seismic waves are the waves generated by earthquake waves, and these methods based on the observation of velocity of elastic waves through the subsurface formation. And there are two variations in the seismic survey. First one is refraction method and reflection method. Coming to the reflection method, it is suitable for determining formation boundaries at greater depth of several thousands of meters and needed for oil exploration. For mainly oil exploration purpose, this type of reflection method is used. So, in this method is suitable for the oil exploration, that is, the boundary at greater depth is measured by this type of reflection method. Coming to the refraction method, it is readily applied to shallow depth engineering geological purpose for site investigations and all. Refraction method is mainly suitable for shallow depth, and reflection method is generally suitable for greater depth, that is for oil exploration and all. These are the two methods coming under this category. Working of this. So, in the refraction survey, a number of geophones are placed at regular intervals from the point of explosive charge of hammer drop. So, in the reflection survey we are using a number of geophones, and they are placed at regular intervals from the point of explosive charge. The time taken by the seismic refracted waves to reach the station after the shock is recorded accurately, and the seismic velocity versus with the depth information as available from such survey is then interpreted to give an idea about depth of the geological formation. So, here you are using refraction survey and time taken by the seismic wave refracted waves to reach the stations after the shock is recorded, and from this we can find the available from this we can survey is well interpreted to give an idea about the depth of. So, with this we will get an idea about the depth of the geological formations. Seismic waves, and from the calculated investigations we can find out seismic waves travels faster in denser and elastic rocks. Their velocity gets considerably reduced when they encounter unconsolidated, poorly consolidated, porous or saturated rock formation. So, depending upon the velocities of the seismic waves we can interpret this type of techniques. Next is the gravimetric methods. This is mainly based on the density of subsurface sediments or formation has a pronounced influence on the gravitational attraction of the earth at a particular location. When gravity measurements are taken along different directions in aquifer given area, normally expect a uniform gravity value if it is the same material that exists below. So, if the material is uniform, it is expected to have a uniform gravity value. But if during such survey exceptionally high or exceptionally low values are observed along certain directions. So, this is referred to as a gravity anomaly, or that means if there is an exceptional variation in the values, we can interpret that there is a gravity anomaly in that particular area. If the gravity anomaly higher than the normal, denser material is buried below it is indicated. It may be an ore of a mineral. So, depending upon the gravity anomaly, if the anomaly is higher than the normal one, a denser material is buried below is indicated. If the anomaly is on the lower side, or if the anomaly is having lower value, lighter material is buried below is indicated, which may be an aquifer, a porous rock saturated with water. Next is the electromagnetic surveys. In electromagnetic exploration, electromagnetic waves at very high frequency are made to propagate through the ground for recording such properties as magnetic permeability, electrical conductivity and dielectric constant. The instruments used for such frequency electromagnetic surveys are called ground penetrating radars, and using this instrument we are determining the survey method. The effective depth of penetration for higher frequency electromagnetic surveys is usually limited to a range of 14 to 15 meters. Next is the remote sensing, an increasingly valuable tool for understanding groundwater conditions. So, remote sensing is nowadays tremendously increasing, and with this remote sensing technique we can locate the groundwater potential of a particular area. It is the process of obtaining information about an object by a sensor that is not in physical contact with the object, by measuring the portion of reflected or emitted electromagnetic radiation from the earth's surface. So, in the remote sensing, it is a process of obtaining information about an object by a sensor. So, you are using sensors to sense the information about an object, and that is not in physical contact with the object, by measuring the portion of reflected or emitted electromagnetic radiation from the earth's surface. And the difference in reflectance properties of objects produce varying signatures on the photos or images, which can be interpreted for a variety of purposes, of which application of hydrogeology is one among that. So, depending upon the options, we can use remote sensing techniques to find out the groundwater potentials. So, this is a figure. Process of remote sensing is explained in this figure. So, in this figure, sun is the source of electromagnetic energy, and electromagnetic radiations or EMR produced by the sun travels through the atmosphere and interacts with the earth's surface features, and these radiations which are not absorbed by the surface get reflected, and this reflected energy is captured by the sensors on board the satellite. So, here you can see the sun is the electromagnetic source or energy. From the sun radiations are coming, part of it is absorbed by the surface, a part of it is reflected back, and the radiations which are not absorbed by the surface gets reflected, and this reflected energy is captured by the sensors on board the satellite. So, here some part of the radiations are not captured or not absorbed, it is reflected and it goes to the sensor and reflected, and this reflected energy is captured by the sensor on board the satellite. Also, we are using stereoscopic air photos. It includes color, black and white, infrared, oblique air photos and high resolution satellite imageries open up new possibilities for the assessment of groundwater resources. So, all these things are used for the assessment of groundwater resources. That means stereoscopic air photos, it includes color, black and white, infrared, oblique air photos. high resolution satellite imageries. These are all used for the assessment of groundwater resources. Observable patterns like color and relief make it possible to distinguish difference in geology, soils, soil moisture, vegetation and land use. So, there are so many characters which can be observable from the patterns, color, relief. This all distinguishes differences in geology, soil, soil moisture, vegetation and land use. Hence, area of groundwater recharge and discharge. So, from this we get a clear idea about the groundwater recharge and discharge of that particular area. The remote sensing technique is only an additional tool in the quest of groundwater and not a substitute for other methods. For a meaningful interpretation, there should be adequate ground check in the field. So, with remote sensing only we can't find groundwater potentials, it is only an additional tool. With the help of remote sensing technique, you can use some other techniques, you can add some other techniques. There should be adequate ground check in the field, then only you can use these remote sensing techniques added with geological and geophysical method favors the groundwater exploration. With the help of the remote sensing technique, we can demarcate groundwater potential zones and we can also identify groundwater recharge site, and by using this technique we can analysis for future artificial recharge sites. The high resolution satellite images are interpreted to identify the groundwater potential source. The groundwater potential source is mainly interpreted by high resolution satellite images. So, it can be done with visually or digitally. Thematic layers are prepared based on hydrogeomorphic units, land use, land cover, lineaments, rock types, structures and many other features. So, we are using thematic layers, and preparing thematic layers are prepared and based on the hydrogeographic units, and also with the help of land use, land cover, lineaments, rock types, structures and many other features we are interpreting this. The methodology involves the delineation of hydrogeomorphic units which are influenced by the hydrogeological conditions of the area. The hydrogeological conditions are mainly controlled by lithology, geomorphology, structures like lineaments, faults and fractures. Hydrogeological condition of a particular area is mainly controlled by lithology. Lithology means rock types, geomorphology means that morphological area of that particular area. Then structures. So, structures includes lineaments, faults, fractures, etc. The visual interpretation of satellite data in conjunction with limited field verification of these features will focus on the priority zones. Most of them are reflected as hydrogeomorphic units. Remote sensing provides the distribution of these units. Now, let us look back again to the main points discussed in this episode. So, we discussed about the groundwater prospecting. Mainly, there are three types of groundwater prospecting techniques: geological investigations, geophysical investigations and investigations using remote sensing. Coming to the geological investigation, the first step includes geological mapping, then study of mode of origin and petrological features of the rock and study of aquifer structure. Geophysical investigations include gravitational, magnetic, seismic and radioactive method. The various methods are discussed here: electrical or resistivity, magnetic method, electromagnetic method, gravimetric method, seismic method. In electrical methods, we are using two types, two resistivity type methods are used. One is Venner configuration and second one is Schlumberger configuration. In Venner configuration, we are using two electrodes M and N and current electrodes A and B, and all these are placed at equidistance. And in Schlumberger configuration, we are using the same 4 electrodes and we are placing it distance between the potential difference, we are placing it little bit far away. So, the configuration is little bit different in the Schlumberger configuration. Seismic method, there are 2 types of seismic survey. One is refraction method and another one is reflection method. Reflection method is mainly suitable for greater depth investigations, that is mainly used for oil exploration. Refraction method is mainly applied to the shallow depth engineering purposes like civil engineering, site investigation and all. For using, we are using so many refraction surveys, a number of geophones are placed, and based on the geophones and the time taken by the seismic refracted waves to reach the stations after shock is recorded, and based on this calculations are done. Next is the gravimetric methods. The density of subsurface sediments or formation has a pronounced influence when with gravity measurements are taken along different directions in aquifer given area. Normally expect a uniform gravity value. Based on the anomaly recorded, we can find out this survey. Next is the electromagnetic survey. In electromagnetic exploration, we are using electromagnetic waves at very high frequency are made to propagate through the ground for recording such properties as magnetic permeability, electrical conductivity and dielectric constant. So, we are using ground penetrating radars for this purpose. And the last technique is the remote sensing, and it is an increasingly valuable tool for understanding groundwater condition. And in this, it is the process of obtaining information about an object by a sensor that is not in physical contact with the object by measuring the portion of reflected or emitted electromagnetic radiation from the earth's surface. Based on the difference in reflected properties, we can interpret this data. So, here the process is explained in this figure. Sun is the main source of electromagnetic energy, and this electromagnetic radiations produced by the sun travels through the atmosphere and interacts with the earth's surface features. So, these radiation which are not absorbed by the surface gets reflected, and this reflected energy is captured by sensors on board the satellite. And in this we are using stereoscopic air photos, oblique air photos, satellite imageries, etc. Based on the observable pattern, color and relief make it difference and it helps to distinguish difference in geology, soil, soil moisture, vegetation and land use. Remote sensing techniques help in the demarcation of groundwater potential zones, identification of groundwater recharge site and for the analysis of future artificial recharge site. For this, we are using high resolution satellite images are used and interpreted to identify the groundwater potential. Also, thematic layers are prepared based on the hydrogeomorphic units. With this, we come to the end of the groundwater series. In the earlier episodes, we discussed about groundwater sources, distribution, geological work, water quality, etc. Hope you have understood all the things discussed in the previous episodes. Thank you for watching this program. Goodbye.